Hi guys, welcome back. So today we are going to be looking at proportions. Our goal for the day is that we can explain the relationship between our variables within an equation and explain how changing one variable will impact the value of another. So what we're really going to be doing today is building on our understanding on the relationship between variables that we started looking at in linearizing data. So we are going to see how changing one variable within an equation, whether we increase or decrease the value of that variable, will impact the other values within that equation. Okay, so let's go ahead and look at an example. Let's say we have the equation that E is equal to 1/2 kx squared. We want to see how changing the value of our k in this equation is going to affect the value of our variable e. The first thing we want to do when we're approaching these problems is see what relationship do we have between k and e. And we are going to see that we are going to have a direct relationship there. Okay? And we know that we have a direct relationship because we can really think of this as y is equal to x. So as x increases, our y value is going to increase by the same amount. Since we don't have any exponents here, and x is not in the denominator. What that tells us is, if we double k, double our value of k, since we have a direct relationship, the same thing is going to happen to our value for e. So if we double k, e is also going to double. Okay. Another way that we can look at this is, we can plug in that multiplier into our equation. So if we double k, it's really like we now have 2k in our expression. If we pull that multiplier out to the front, we're going to see that we have 2 times our initial 1/2 kx squared, or 2 times our initial value for e. Okay. So there's kind of two ways we can think about this. We can think, what kind of relationship do we have between k and e? If it's a direct relationship, whatever we do to k, the same thing will happen to our e. So if we double our value for k, that means our value for e is also going to double. Or we can plug in that multiplier into our expression and see how it changes our original value. So let's say we go ahead and look at that expression again. So again, we have e is equal to 1/2 kx squared. But this time, we're going to focus on our relationship between our x and our e. Okay? So we can see here in this example, we have the exponent attached to our x variable. So that tells us between e and x, we are going to have a direct square relationship. Okay? Because we can see that e, or our y value, is going to be proportional to x squared in our expression. Okay, so this tells us we have a direct square. So that means, in this case, whatever we do to x, the square of that will happen to e. So if we double x, since it's a direct square relationship, that means our e value will quadruple. Okay, because we're multiplying x by 2, which means the square of that will happen to our e value, and we're going to find that our value for our e variable is going to be multiplied by 4. If we wanted to think about this the second way, we could also plug in that multiplier into our expression. So we have, in this case, e equals 1/2 k times 2x squared. Okay, it's super important that we put that 2 in the parentheses with our x because the whole thing is going to be squared. Now we can see if we were to rewrite this, we would have 1/2 k times 4x squared. Okay, because 2 squared is going to give us that 4. If we pull that 4 out to the front, we are going to see that we now have 4 times our initial 1/2 kx squared, or 4 times our initial value for e. So no matter which way you think about this, we can see that we're going to have 4 times our original value for e. We're looking at that 1/2 kx squared expression. We want to see what will happen for our value of e if we have 1/3 of our x value. Okay, so here we're multiplying x by 1/3, and we want to see how will that affect our value for e. So again, if we look at our relationship between e and x, we're going to see that we have a direct square relationship. So that means whatever we do to x, the square of that will happen to e. So if we have 1/3, we'll want to square that to see how our e value will be affected. And we're going to see then that we'll have 1/9 of our original e value. Okay. So if it's direct squared, the square of whatever we do to our x will be what happens to our value for e. So if we take the square of 1/3, we get 1/9. So we're going to have 1/9 of our original e value. If we think about this the other way, we can plug in that multiplier into our expression. So we have 1/2 k, and now we have 1/3 of our original x. Okay. Remember, make sure you square that 1/3 as well as the x, because that 1/3 is attached to our x variable. We can see then that we'd have 1/2 k times 1/9 x squared. And when we pull that 1/9 out to the front, we're going to see that we have 1/9 of our original 1/2 kx squared, or 1/9 of our original e value. So you guys can think about this either way. It's just what makes more sense to you. Take a look at one more expression. So in this case, we have b is equal to d divided by t. So we have some different relationships in this guy. So our first question is going to be, what will happen to v if our value for t is divided by 5? Okay, so if we have 1/5 of our t value, divide t by 5, what will happen to v? So what we can first do is see what relationship do we have between v and t. And we are going to see that these guys are an inverse relationship. So that means whatever we do to our value for t, the inverse or the opposite of that will happen to v. So if we have 1/5 of our t value, that means we're going to have the inverse or opposite effect on our value for v, which means we're going to have 5 times our original value for v. Okay? And this makes sense because if we're inverse, if t gets smaller, that means our value for v is going to get larger. So that's a good hint that we're going to be multiplying here instead of dividing. Another way we could do this is if we plug in that 5 right into our expression, or sorry, 1/5, because we're dividing that t by 5. We can then see that that's going to be the same thing as 5 times our original v over t value, because dividing by a fraction is the same thing as multiplying by the reciprocal. And we will have 5 times our original value for v. Expression again. So we have v is equal to d over t. But this time we're going to make it a little bit more complicated. Let's say d and t is divided by 3. What would happen to v? So if we double our value for d, divide our value for t by 3, what is our new v value going to be? So for these guys, this is where I do think it's easier to just plug that multiplier into your expression. So we have in our expression 2 times our original value for d, and we're dividing t by 3, or taking 1/3 of our original value for t. We want to pull those multipliers out to the front so we can see how it's impacting our value for d divided by t as a whole. Okay, so here we have 2 divided by 1/3, so we're just pulling that out to the front, times d divided by t. Okay, so I just pulled those multipliers out to the front. We can then see that if we have 2 divided by 1/3, that's the same thing as saying 2 times 3 over 1, since dividing by a fraction is the same thing as multiplying by a reciprocal. So we can really just say that we have 6 times our original value of d divided by t, or 6 times our original value for v. Okay? So if we double our value for d, divide our value for t by 3, our original value for v would have been multiplied by 6. I hope this helps. Please let us know if you have any questions as you're working. Otherwise, have a great day.